to this Alluvial Fan Webinar. I'm Dr. Sean Zhang, Associate Professor of Teacher Education at the University of Nevada, Las Vegas. Today, it's my pleasure to be the MC for this very special webinar. We're counting down 4 days to the launch of Perseverance rover to Mars on July 30th. Today, we have our Nevada State winning team, Journey to Mars, to present us their project experience on Rows on Mars Challenge. The Rows on Mars Challenge is organized by NESSP, Northwest Earth and Space Sciences Pipeline, which gives students in grades 3 to 12 a chance to tackle a mission to Mars. Journey to Mars is the winner of Rows on Mars Mini Challenge, Landscape Morphology. Next, we'll first have the Journey to Mars team members, Ms. Sarah Chen and Ms. Linfei Wang, to present their work. Ms. Sarah Chen, would you please introduce yourself?
Hello, I'm Sarah Chen.
Hi, Ms. Linfei Wang, would you introduce yourself?
Hi, I'm Linfei Wang.
They will answer questions from the audience after they presented their project. Audience, we are so honored to have you here today. But before we start, please turn off your camera, mute your microphone, and if you have any interesting questions, please type them in chat. Okay, let's get started.
Alluvial fans, is there water on Mars? Sarah Chen and Linfei Wang. What is an alluvial fan and how does it form? Alluvial fans are a fan-shaped sediment deposit. These are created when water traveling in between two mountains or a canyon carries the sediment, sand, dirt, or rock that rests at the bottom of the river to an open area where the water flows outward naturally to create a fan shape.
So in this diagram, you can see there are two mountains, and in between the two mountains, you can see there is a narrow pathway, and the narrow pathway leads to a very open area where the water flows out and carries the sediment and to create a fan shape. This is an alluvial fan from Death Valley National Park. It is formed by rainstorms flooding through the valley. The size is relatively small but distinct. The cracks are formed by lateral spreading of the fan during earthquake events. So as you can see there, you can see this big line around the fan, and that is because people decided to build a road around this alluvial fan because it is pretty flat. So this is an alluvial fan in Taklamakan Desert in Xinjiang, China. It is about 60 kilometers long, which is really long. The left side is the active part of the fan and appears blue from the Mocha River water flowing in from many small streams.
Why are alluvial fans important? Alluvial fans are created by water, so anywhere you see an alluvial fan is where there is or once was water. Alluvial fans can show the history of one place, such as on Mars. Alluvial fans are of practical and economic importance to everyone, particularly in waterless dry areas where they might be the principal groundwater source for irrigation farming in the sustenance of life. For example, entire cities like Los Angeles have built on alluvial fans.
So this is an alluvial fan from the Himalayan mountains. And this is a picture of Los Angeles, which is a city that has been built on one large alluvial fan.
What alluvial fans have to do with Mars? Scientists are trying to figure out if there is life on Mars, and all life needs water. Knowing that there are a few alluvial fans on Mars can let us know that there is water on Mars. This can mean that there was once life on Mars. Of course, we don't know for sure. The alluvial fan on Mars is formed in a crater, so in 2 of our trials, we made craters using rocks.
This is a crater on Mars, and this is a crater with an alluvial fan on Mars, and here you can see the alluvial fan. This is the Ubehebe crater, which is a large volcanic crater beyond the northern end of Death Valley National Park. The crater is 1 kilometer wide. Within Ubehebe, small alluvial fans have been built on the crater wall along with talus slumps from deeper flows. This is the Jezero crater on Mars, which is also a crater with an alluvial fan inside of it. The diameter of the crater is about 49 kilometers, and the fan inside is assumed to be created by water. Of course, the coloring just represents the minerals on Mars. It doesn't actually mean that Mars is colorful. And this is just a side-by-side comparison of a crater with an alluvial fan inside of it on Earth and on Mars.
Our experiments. Hypothesis. The alluvial fan is formed with water. The water travels and takes sediment with it while it is flowing down a slope and brings the sand to an opening of the river to form a fan. So our hypothesis was, the faster the flow, the bigger the fan. So the objective of all this was to prove or disprove our hypothesis and to learn about alluvial fans.
Variables. Possible independent variables. Amount of sand, the looseness of the sand, the wetness of the sand, and the amount of water that flows down. Independent variables we are interested in, the amount of water that flows down. Control variable, angle of slope, the speed of the water, how we pour the water, and the number of obstacles. Dependent variable, the width, length, and number of the fans.
Creating an alluvial fan. Materials: 2.5 gallons of water, food dye, we used blue and pink, 1 large leak-proof container, around 20 times 40 inches or 2 times 4 feet, 1 50-pound bag of white sand or place sand, 1 bucket of colored water sand, a slightly sloped surface on our, we used our driveway, it was about a 5-degree slope, gloves, a measuring cup to scoop the water from the bucket.
Steps. We set up our container on our driveway. We laid out the bag of sand into the container, leaving about 1.5 feet of room left over. The sand was about 2 inches high, and we added a tunnel for some experiments and left it flat for other experiments. We filled our bucket with about 3 gallons of water. Colored our water blue the first time and pink the second time. We poured the water down the tunnel when we had one and watched as our alluvial fan formed. We added some obstacles to the flat experiment and added rocks to form a crater for one of the tunnel experiments.
As you can see here on the right, this was one of our experiments. So for this one, we didn't have a tunnel, we just poured it just directly onto the sand. So in the beginning, when we poured the water split into 2 rivers. So that formed 2 alluvial fans. Eventually the fans became bigger and bigger until they just became 1 big fan.
Alluvial fan details. In alluvial fans, there will be vessels or pathways which form when water finds a way it likes to go. It will keep going that way until a small path is formed. Of course, the small branch-like vessels in real life are actually massive. So on the picture on the right, you can see that there are small branch-like vessels from the water flowing in from very many small streams. So here's the video for our alluvial fans. For this first alluvial fan, we had the rocks on the edges to form a kind of crater at the end, and we had a straight tunnel. For this first one, we did a flood-like experiment where we poured the water gradually, because sometimes alluvial fans are formed from a yearly flood, not necessarily just one-time flood. So for this first fan, the result was a triangular shaped fan.
Here you can see our tunnel is curved, not straight, and we didn't have a crater at the end. So this crater was actually one of our bigger ones. This alluvial fan was one of our bigger ones. This was because the curve of the tunnel. So the water, when it's flowing down, will rub against the curves, carrying the sediment down and then depositing it to create a bigger alluvial fan. So this one was the one without any tunnels. We just poured it straight onto the sand. As you can see, the two fans you can very clearly see them this time.
So for this alluvial fans, we also made a crater at the end with a straight tunnel. And this time we didn't do the flood-like environment. Instead, we poured the water straight down. And I think because it had a faster flow, the fan became our longest fan. So our hypothesis was half correct, because our hypothesis was the faster the flow, the bigger the fan. And this one had a fast flow, creating our longest fan.
As you can see here, this was actually just a duplicate of the first. This was actually our second trial, but with the same environment as the first one in the video. As you can see, this one also formed a very pointy-like fan.
Results. The fan without any blockage is our widest one. And the fan with the obstacles in the middle caused the split of water flow, resulting in two smaller fans, which eventually became one large one. The fan with our crater at the end and the continuous flow is our longest one. And in the picture on the right here is our fan without any blockage.
Okay, sources and acknowledgements. So these were our sources. We'd like to thank NESSP, Roads on Mars Challenge, because without them, we wouldn't have learned about alluvial fans. And we'd also like to thank Nova 77 Workshops and Mentoring, because without them, we wouldn't have found out about this challenge. So,
Thank you for listening.
any questions? How many trials did you try? We had around 8 trials. 5 of them worked, and then 3 of them just something went wrong and